destroyed. If passengers were here traveling, imagine what would have happened to them. It blew it onto the highway on the way to Asoko. Everywhere is destroyed. This Kugbo-Abuja terminal built by Wike, one rainfall, everything is destroyed. If it was going, or if passengers were in these premises, imagine what would have happened to them. This is crazy, man. Everywhere is blocked. It's destroyed. If passengers were here traveling.
Good morning, everybody. Something that's a very terrible thing happened in Abuja, and it's really unfortunate that's had to happen. No one is happy about it. Kugbo is between, if you know Abuja very well, Kugbo is in between AYA and Nyanya. If you are leaving Asokoro and going towards AYA, there's a hill. So that place is Kugbo. So apparently, and it failed due to weather conditions, But what I don't like about this is calling Wiki. This is not about Wiki. It's a pandemic that we need to handle. And we don't have to handle with levity. We have to really pay attention to things like this. So I'm here today because this concerns steel. This is structural steel failure. I know we've been talking about steel. I intend sharing my ideas about steel. So it is important that we treat the forensics, understand the probable reasons while that structure failed. Structures do fail if some things are not put into consideration. So number one, I want us to quickly talk about the likely failure and what led to the Kugbo-Abuja terminal collapse. So number one is improper design. If a structure is not properly designed, and I've been telling you, I've been explaining in the previous videos, if you've been watching, following up with the videos, you understand that I always emphasize on design. That is the first step. Design involves putting all these conditions that can cause failures into consideration. For example, this roof must have put what it will support. For example, there will be roofing sheets. Roofing sheets have different weights. Usually they come in weight per meter, weight per square meter. Okay, so it's like 1 meter by 1 meter, there's a weight. So that is the standard way of considering their weight. Okay, so usually they come in weight per meter. Some can have kg per square meters and all that. So usually they come per meter. So you put all this into consideration. Number one, the roof that you intend using. You put that right at the, as a structural engineer. Number two, you consider your purlines. What purlines? You also design your purlines to know what to span the center to center. If you're an engineer, but I would like as much as possible to summarize this video. You consider your purlines, you must have done the designs, and then the other parts. You also consider insulation. Insulation, they have their own thicknesses and it's usually quite heavy. You also consider solar, because these days a lot of people mount solar, and solar has its own weight, 0.75 kg per square meters. Okay, for example. So you have some other things that you need to add. Then fixings, electrical fixings, these things too have their own weight. You need to consider that as part of your structural design. You also look at if probably people will be accessing the place. You have access. It can be 1.5, it can be 0.75, if you understand what I mean. Okay, so you put all this into consideration. Usually structural engineers will say that is classified as dead load. You put that one aside. You now look at the live load that I said earlier, that the people might have access, movable, you want to move around that place, you want to do maintenance up there, you want to carry some machines to go and do maintenance on the roof, it will be catered for. Then another thing is wind load. You also consider the wind. So the wind load, because different geographic locations have their own wind speed. Like in Lagos, you might not have wind speed as much as you have in Abuja. So engineers in Abuja or wherever you're designing from, you need to have the data of your locality. You consider that, look at the wind speed, that culminates into the wind load. It is very important. And sometimes this wind can be sustained and wreak havoc, as we have seen here in Kugbo. So another thing, once design has been done, the structural engineer will look at the depths. As you can see in this video, it's a truss. It's a truss system. You can see that it's a truss system.
Imagine what would have happened today. It blew it onto the highway.
This is a truss system. So usually truss system is what supports your roof, of course, So the truss system has this kind of triangular internal networks. We call them vertical and diagonal braces. Okay, so once you have that designed, you now specify the materials. In this case, they use CHS, that's circular hollow section. It's round pipe. So the round pipe of maybe CHS 75 mm can have thickness of 6 mm. If your design says use particular thickness, that is what the fabricator must use. So let's now go into giving the job to the fabricator. So the fabricator should have his own in-house engineers as well. So engineers that can now interpret what the structural engineer has designed. So the structural engineer will now send this design to the fabricator. The fabricator in turn has his own engineer who understands how to interpret and make detailed engineering drawing. Now, what does this detailed engineering drawing entail? Number one, it has the GA, how everything will look like, general assembly. Number two, it has the sections, details, the connection detail, how this truss system will connect to the concrete. In this case, I'll suggest anything as massive as this should have your anchor bolt designed for and installed. Anchor bolt is like this. Then the bottom is, I'll be showing you all these things, I will show you real life so that you can understand. For those of you who don't really understand steel members. Okay, so the anchor bolt has to be anchored and then has to be shown in your shop drawing. So that shop drawing has to be prepared by an engineer, okay, under the employment of a fabricator. So the fabricator is not just anyhow roadside. No. That's why a fabricator does not mean you should not know what you're doing. You need to have an engineer working with you who understands what the structural engineer has designed and then interprets. So you need to show everybody in that your shop drawing the depth, the anchorage, how you intend, doing the spacing of in relation to the, truss system, the spacing, okay? That probably have not been done. Because that will now have to, once the shop drawing has been done, you now have to send back to the structural engineer. Structural engineer will now approve, okay, that this is what I've asked you to do. Then, the third, you now have to fabricate. So the fabrication is the reality. First, you need to buy your materials. Once you procure these materials, ensure that what they designed is what they designed and what is in the shop drawing is what you are buying. If the structural engineer has designed for CHS 80 mm by 8 mm thick pipe, that is what you need to use. Use your vernier caliper, look at the thickness of that pipe. Check the thickness of the pipe, ensure that that is what, because the structural engineer is working based on data. He has considered code, okay, he has designed based on code. So all these things have to be documented and then you have to follow the documentation. So here in Kugbo, it's possible that the anchorage is very poor and then it failed because most structures fail from anchorage where that steel framing connects to the concrete. So that is where it fails. So once it pulls out from that point, everything is very easy for wind to carry it. That thing, once it's open, wind can do anything if you see the effect of wind. Now let me share this with you. Many years ago, like 5 years ago, or maybe 6, I won't mention the name of the project, somewhere in Ogun State. Luckily, the pupils were on holidays, and wind came, removed the whole roof, and placed it on the road. So I went there for forensics. It wasn't my project, but yeah, I was called upon to go and check. I checked it, and I saw that the anchorage was very poor. These are the issues. The anchorage was very poor. In fact, the anchorage was not even up to 100 mm, and the thickness of the anchorage of the J boat, it was not even a J, it was even a straight boat, no anchor into the concrete, and the concrete was not that properly cured. So these are the things that structural engineer has to be involved in. Once you design, make sure you also check. They send a shop drawing to you that they want to use for fabrication, because nobody uses design drawings for fabrication. So they need to send these drawings, okay, to the structural engineer for approval. So once this has been approved, you now have to follow up with the fabrication as well. So during the fabrication, you also need to have engineers involved. We take a lot of things for granted in this country, particularly Abuja. Lagos is even far more structured. Even with the way Lagos is structured, there are still collapses. On top of Abuja, where people just do things anyhow. People will just they won't even do any detailed drawing that shows exactly what they need to do. They will just give design drawing from probably one of these design softwares, maybe Star Pro that draws lines. They give it to the fabricator. This is where I go. No, you don't do that. You don't do that. You need to follow a lot of code, particularly for welding. Welding, if it says intermittent welding, make it intermittent. If it says continuous welding, make it continuous. Because structure, once you have maybe pipe welding, you don't make it intermittent, you make it full welding. If you are welding pipe to an end plate, that's round pipe, you have to make it circular. It has to go round completely and locked. You don't weld 75% and leave the remaining. You don't do that. If you do that, that thing will start to tear from there. It might just fail in 5 years' time. Like in this case, Kugbo bus terminal that failed after 9 months. Okay, so all these things have to be put into consideration. Okay, so the engineer has to be involved. Check the welding, what the inspectors. Check what the inspector has done. Check his PQR, WPR, his what's it called now? PQR is a procedural qualification record. Yes, procedural qualification record. Look at the way he intends to do all this welding and all that, the thicknesses, everything. Make sure everything is welded properly before you now release for painting, and then even during the erection as well. You need to also look at the way it's being erected. These things have to be followed up. An engineer has to be involved. An engineer has to be involved. Although they are yet to do investigations, we don't know the cause of this failure. But sincerely, this is not blaming Wiki. I don't care about who is a minister. I think he studied law. I don't know what he studied, but he's not an engineer. This is not a good thing, and it is not the time to put blames on anybody. If you're an engineer, it's a big slap on your face. Yes, it's a big slap. If you live around that area and you see that work being done, and you don't go there once in a while to go and to probably just check. If you're an engineer, you're moving around. A lot of engineers are in Abuja. If you're an engineer, you're doing anything around that is within your expertise, there's nothing wrong going there. If you see anything wrong, flag it up. Escalate it. You know how to do that. Yes. If you see anything wrong in your area, as a Nigerian engineer, flag it up, because this is not a good thing. It's not about you, your company is good. No, it's a big slap on Nigerian engineers that these things are still happening in Nigeria. Thank you very much.